Okay, question 18. Looks like I'm going to have to earn my money today. A lot longer. It's actually not too bad. We have a, let's go ahead and go with red. We have a formula here with V. What is V? Particle release is part of an experiment. Speed t seconds, so this velocity. Speed t seconds after release is given by this, where V of t is in meters per second. And actually velocity has direction as well, so they're calling it just speed, but that's fine. How far does the particle travel during the first 3 seconds? So that's accumulated. Remember, this is speed is just is a rate of change. Distance is accumulation. Also, when we had distance, when we took its derivative, that's what gave us velocity. So velocity is a derivative, so when we integrate velocity, we get back to the position function, which we usually called s. How far does it travel during the second 3 seconds? So the particle travels. So what we want to do is integrate first time from 0 to 3 during the second 3, so then we want to go from 3 to 6, right? So integral minus 0.3 t squared plus 4t dt. First time for a part, we're going to go from 0 to 3. Second part, we're going to go from 3 to 6. Okay, so we integrate it. The integration is going to be the same in each case, and again we integrate by adding 1 to the exponent, so that's going to become t to the third, dividing by that new exponent, that's 3, and then any constants just tag along for the ride. This is t to the first power. We add a 1 to it, so that's going to be t squared. We divide by that exponent, and the 4 tags along for the ride. We got a plus in between, and we can simplify, but we can do it as we go as well. We want to see from 0 to 3 what is the accumulated distance, the speed. Speed is how fast it happened, how fast they're moving. The integral gives us how much distance was traveled. The good thing is we got a shortcut here. If we plug in 0, the second part is just 0, so we're subtracting 0, nothing to worry about. So we really just focus on plugging in 3 to each of these. So we get minus 0.3, 3 to the third over 3 plus 4, 3 squared over 2. And we don't need to worry about the 0 because that's all 0. Round to 2 decimal places as needed. The other thing is, hey, we could do it with a graphing calculator. Since we want a decimal anyway, so let's go ahead and do that sort of as a check. You could do both ways. So we go to y equals, we're going to enter in the function negative 0.3 x squared plus 4x, and we're going to go from 0 to 3 and then 0 and then 3 to 6. So let's set our window. I'll leave that at negative 2 so I can see something, and then we'll go to maybe like 8. So that's just going to give us enough room in the x direction. The y direction is we're going up to 10. That should be enough, I think. I don't know, maybe not. We'll graph it and we'll see. Wow, it gets big. It's not enough. Not quite enough. So we're going to come back to our window. We're going to make our y max, or yeah, y max. Let's make it 25. I think that should do it. Then so that gives us plenty. And then what I do is I go second calc. I integrate numerically with the lower limit of 0 and an upper limit of 3. What I like here is you actually see what you're getting. You get the area under the curve, and it says it's 15.3. We'll verify that, but that's what we should get there. And then, but the nice part is we could we could go ahead and say, okay, what happens the second time? Let's just do the same thing. Second calc, number 7. But now the lower limit will be 3 and the upper limit will be 6. Okay, so the calculations would be, and again it fills in, but that's just the new stuff, 35.1. And on this one we would have had to do more work because you've got to do the subtraction part and all that kind of stuff. But I'll let you double check on those if you so choose. But you can use the technology. 2 decimal places. They only had 1. Okay. We really didn't need a round. So that's 18, question 18.